Hey everybody! Hope you are excited, at least as excited as we are about this Athlete Climate Academy. And it's a good opportunity to have all of you here. Me as an athlete, the first one, I'm super thrilled to learn about climate science and to learn about environment because we spend a lot of time in the outdoors. It's our playground. It's where we are all the time. But we don't know much about it, or I don't know much about it. Like I know how to run, I know how to ski, but I don't know what's in the snow. I don't know what's in the soil. So I think that's a great opportunity for me first to learn about climate science, and I couldn't find a better person to explain all of this than Hugh. So hey Hugh, how are you doing?
I'm good, thank you, Killian. It sounds like when you said I couldn't find a person better than this, that you actively looked for someone, and literally just couldn't find anyone that was couldn't find anyone. So he was here. I'll introduce myself though, because people probably know you. My name's Hugh James. I'm a science communicator. I live in Wales in the UK, and we've been working on this climate academy now for a while, right? We've been putting content together, like up on the website at athleteclimateacademy.com. There's interviews with scientists, there's interviews with other athletes, there's you can listen to the podcasts on things like Spotify. There's downloads and animations to put into things. So we've been working hard, kind of scribbling away in the background to put this together. But this is our first kind of going live, which I'm excited about, but also feel pressured because I'm running the whole show. And I know for a fact, having done stuff through COVID, that this stuff can all go terribly wrong. So let's see how it goes. If any of us falls off the radar, the other one will pick it up. And if electricity crashes and everything, then that's fine too. Zen.
And you can see like you're a professional. Like look your background. Like you have here the microphone. You have all the stuff
Yeah.
like to control all the cameras and the videos. And I'm just like in my band. So like we can see who's the expert here.
Well, I love
So
that we were just talking about Donde Está Waldo and like finding out where Killian is during each of these interviews, parked outside someone else's house or in a different supermarket. So yeah, we've got a bunch of great pre-records and interviews with different scientists and athletes, and Killian's done some and I've done some as well. But yeah, well, I said to Killian early on that all the best kind of professionals and journalists for good sound, they always do it from the back of their van. It's not quite true. Killian chose it, but yeah, it works well. I think it's good sound in the back of your van.
yeah, it's good sound, and I think it's like we like the approach we have on that the early climate academy is to be real and to talk with people that know about things. Like, and we can say like I don't know about technology. I'm just in my band. Like Hugh knows very well about what he's doing, and he knows about science. And we has been inviting different experts in very different fields. Like they mentioned, like from snow to soil to energy to advocacy, and it's a bunch of experts and scientists that has been joining us on the different episodes that you can find on the website, and also in the live sessions like the one today. Uh, Now we will be actually chatting together and putting um, some different interviews that we did for the next couple of hours. We will keep doing these kind of live streamings. We do another one in Thursday, and then it will be some updates in the next month. You can see everything on the Early Climate Academy. And as you mentioned, it's in the website that you can find like the interviews with the experts also in different formats, YouTube or podcast. So actually, one of the first things is we talk a lot about climate, like it's everywhere in the news, it's everywhere in the discussions, in conversations. But what's climate? What are the grounds that should scary or not scary us as human beings? And yeah, I think many times we get away about the last news, but we don't have. I don't have the ground to understand what really going on. So I think it would be good to build this base, this ground to understand more about climate science, and that's the goal of this session. So I think we can go into it. I think Hugh has prepared a very good introduction into what's climate.
Yeah, you don't have to ask me twice to kind of ramble on about science for any length of time. So what I've done throughout these sessions is thought I put together kind of 10-minute introductions, which is through these, we're never going to kind of steer clear of the science because it's important. But, through a lot of science, we can strip away some of the jargon and some of and just kind of communicate it on simple terms. So hopefully we try our best to do that. We got a couple coming up today on climate and atmosphere and things like that. So I'm hoping that they're going to be a good introduction into it. So here. All right, let's get into Climate 101. What do you need to know about the climate as it was in the past and the climate as it is today? So to talk about what's happening with climate and global warming, we really need to understand where the Earth gets its energy from. And there are 4 big forces at work. There's solar, gravity, radioactive decay, and the rotation of the Earth. Now, solar energy drives many of the surface processes such as wind, currents, the water cycle, and the overall climate system, which is what we want to have a look at today. But things like gravity, that makes rivers and other materials flow downhill, and it creates tides from the moon's gravitational pull. So that's some energy there too. Radioactive decay then creates heat in the Earth's interior, and we get some heat from that too, or some energy from it. And Earth's rotational forces, that influences currents of air and water as well. So all gives energy into the big Earth system. So the majority of our energy and heat does actually come from the sun. It's an absolutely huge ball of nuclear fusion that lies in the heart of our solar system, about 150 million kilometers from Earth. So far away that it takes light 8 minutes to get from the sun, from the outside of the sun, to Earth. But it actually gives us about 173,000 terawatts of energy. That's how much falls on Earth continuously in the form of the Earth's rays. And to put that into perspective, that's more than 10,000 times the world's total energy usage. So it really makes sense that the sun would be a big driver of the Earth's rising or falling temperatures, depending on what it's doing at any particular time. And this is to scale, by the way. This is actually how much energy we use compared to how much solar energy hits the Earth. So over time, the sun is actually getting a little bit hotter. But we're talking over an awfully long time. It's about 5 billion years old, and it'll last for about another 5 billion years. So it's been around. So seeing any major change in the Earth's climate through changes in the sun, it wouldn't really happen. It happens on such a long time scale. We don't see those patterns over a few hundred years. The sun actually does go through cycles, though. Every 11 years, the sun has, which has a huge magnetic field, that goes through a field reversal. So just like you would see in something like a north and south pole of a magnet, the sun has the same thing, and it flips. And it causes the change in output. It can change anything to about 0.15%. So again, would that have an effect on Earth? Well, possibly, but could it cause climate change? Probably not. I mean, the changes we're talking about are really, really small. The changes in the time in which they take place just aren't enough to cause the extent of the warming that we're seeing in our climate today. And there are other factors at play here as well, though. The Earth goes through a few longer cycles that definitely do have an impact on how much energy falls on the Earth from the sun. So one of them is orbit. And the Earth's orbit isn't really round. It's more like an egg or an ellipse shape, just like all orbits in the whole solar system and everywhere in the universe. But so naturally, that means that at some points we'll be a little bit closer to the sun, and at some points we'll be a little bit further away as well. Describe it as an egg, though. I mean, it's exaggerated here for you guys to see, but it's almost a perfect circle. The changes aren't really that much. It goes from being almost a circle to a little more like an egg shape over the course of 100,000 years, so over a long time. Currently, our eccentricity, which is how much that changes from the circular shape to the egg shape, is almost a perfect circle. We do still get a little bit close to the sun, but that's in January, and a little bit further away in June. So that's our closest approach in January. Our furthest away is in June. But these small variations, again, over that time scale, it just isn't enough to cause the warming that we're seeing. Another variation, though, is the tilt of the Earth towards the sun. So over a 40,000 year cycle, the Earth changes its tilt. You might have seen a globe where the Earth doesn't point straight up, and that's because the Earth is tilted over around 23.4 degrees. And that's close to the middle of the range of what the tilt can do. It goes more tilted and less tilted over time. And where we are at 23.4 is around about in the middle. And what that means for the climate is that the more tilted over we are, the more extreme our seasons will be. It's because when we're tilted over, the more solar radiation will fall on Earth in the summer and even less than normal in the winter. But like I said, we're at the midway point of a 40,000 year cycle. So it's not going to have affected the climate that much over the last few hundred years. Okay, the last of these cycles, and these are all called Milankovitch cycles, by the way, a staple of physics. The last of the cycles is down to the Earth's wobble. So the Earth doesn't spin like it does on a globe, perfectly steady. It actually, if you try spinning an egg or maybe a spinning top, you'll see what I mean by the wobble. It kind of wobbles around as it starts to fall over. And this also has an effect on how different parts of the world experience their seasons. But this is a cycle of around 25,000 years. And what's interesting is that the opposite is also happening, which is really weird. Climate change is also having an impact on the wobble of the Earth because of the way the weight is shifting around the Earth. Some parts are finding they're having droughts more. Some are getting kind of mass ice shifts where it melts and flows away. So the wobble of the Earth can cause different amounts of heat to land on the Earth. But also climate change and the changing climate is changing the wobble, which is super strange and a little bit weird. So those are some of the more mechanical processes that affect the Earth's climate, but there are loads more. And there are a number of changes that can cascade down to make a noticeable shift in our climate. And one of the largest is how we retain that heat that arrives here from the sun. So all those processes affect how much heat arrives here, and then it's what we do with it then that's starting to really change. So we receive, store, or sometimes reflect the sun's radiation in a bunch of different ways. Some never gets through our atmosphere. It kind of just stays out there in space. Some is absorbed by our oceans. Some is taken in by plants, and sometimes is stored deep within the Earth. And some is just reflected straight back into space. It hits the Earth, maybe hits something white or bright like an ice cap, and just gets reflected back out. And all these different processes, they make up that cycle of how much energy do we get coming to Earth and how much we keep. And how much energy is coming to Earth, well, that's been the same for a little while now. A long time when we're talking about human lifetimes and human life scales. How much we keep here on Earth, that's what's changing. The climate here on Earth is taking us the temperature, humidity, atmospheric pressure, wind, rainfall, and other meteorological elements on an area of the Earth's surface over a long time. In simple terms, climate is the average condition for about 30 years over a large portion of the globe. So it makes sense that changes we've been making to our planet will affect the Earth in some way. And it turns out it's been making it hotter by altering the greenhouse gases in the atmosphere. That in turn has other effects, and we've started changing the planet faster than it otherwise would be in a natural climate cycle. And it's true that Earth has been hotter in the past. However, at some points there've been little to no ice on the planet at all. It's like a greenhouse Earth or a tropical Earth where there's tropical forests everywhere and everywhere you look. So there's been kind of very little to no ice at points in the past, but there's also been points where we've had the whole planet maybe been covered in ice, call it snowball Earth. So it goes to these natural climate cycles. So, it's also true that there's been more carbon dioxide in the atmosphere in the past as well, and less. So these cycles do occur. But at all of these times, life just generally would have found it really, really hard, if not maybe impossible to survive. And in none of these times did humans walk the planet. Like at the times where there was no ice on the surface of the Earth, or there was ice all over the Earth, and we weren't around at the last time that there were carbon levels this high, we weren't around to see it. So whilst the Earth does go through some natural climate cycles, we now, with all these cycles being at about a medium, about an average, we've hijacked this current cycle, and are changing it in ways that are totally predictable. We kind of predicted this because you dig up fuel from the ground and you burn it, then we can predict what's going to happen. So that's all down to then the carbon cycle, which we're definitely going to cover in a little bit. So I said that we weren't going to shy away from the science, Killian. I got straight in there with Milankovitch cycles and the likes. But I like to lay out like the history and the natural cycles, because we hear it so much, and I'm sure you've heard it in the past, like that climate is a natural cycle, and this global warming event is a natural cycle. And I like to kind of show people that there are natural cycles, but this isn't one of them. Like what we've been seeing over, I'm sure you've seen it as well. Like I've been watching the news with the flooding that's been going on, and the heat waves you just had when you're in the UK, and the wildfires out in the States. Is kind of going, there are natural cycles. This isn't one of them, is what I like to say.
Yeah, exactly. That's a good point out that, of course, the Earth and the galaxy has, and the solar system, it has these cycles, but we are changing it one, and that's why we should be aware, or at least know what's the grounds for that. And being a mountain man, one of the things that they see the most, and that it really surprised, I think, everyone, and it really awakes about its global warming. It's real, and it's here. It's the glaciers. Is that we have been seeing. I'm like 34 years old, and I have been seeing in 30 years how glaciers have disappeared, and how it's changing everywhere in the world. And I think you got a good conversation with one guy that can tell us a lot about that. And I think it's a good example, because he's an athlete, he's a super talented athlete, and he's also a scientist, which I think it's a very good combination. It's people that really can inspire all of us.
Yeah, one of those annoying people that can do pretty much everything. Pascal Legley. Pascal, lovely to talk to you as ever. Welcome to the Athlete Climate Academy.
Hi, thank you.
We got into it quite hard then on, we spoke about everything from glaciers worldwide to the state of glaciers in the Alps. You're out in Switzerland at the moment. And we talked about we go right into like what it actually is a glacier. So I think for this conversation, should we start off about what is your definition of a glacier? See if it differs to mine.
Yes, let's start with that. So, okay, a glacier starts because at a certain altitude, above sea level, usually above 3,000 meters in the Alps, it snows so much that, well, the snow stays for longer than 1 year or even 2 years. And so it becomes a firn, it becomes eternal snow, and that snow compacts and it becomes ice. So, well, a glacier is a glacier as soon as you have like perennial ice that stays for several years. And well, how a glacier works is basically you have this snow accumulating at a certain altitude, because it snows every winter and even in summer, and it compacts, and this dense snow becomes ice, and the ice flows downhill because the mass accumulates, and ice is actually like a viscous fluid. It behaves. It flows downhill, and lower down at some point it reaches an altitude where it's warmer and it melts. So basically, yeah, it's an ice volume that stays for longer than a year, I would say, and it has to have a certain size, but I think that depends who defines it. Yeah.
Yeah, there's definitely some like really tiny. I think I remember seeing the smallest glacier in the world. Was that out in? I think that was out in the States, but it was a very tiny thing that stayed there for a while. That they said was the smallest glacier ever. But I suppose that also differs to an ice cap, which is one that doesn't move under its own steam.
Yeah, actually, an ice cap can also move. Well, an ice cap is maybe special because it's not defined by the altitude, but it's defined by the latitude much more. It's it's cold enough because of the latitude, because of the high latitude. But also, what is very special about ice shelf or so is that it maintains itself. Basically, it reaches a high enough altitude. It maintains itself in equilibrium because it's thick enough. So, for example, Greenland, I mean, it's, let's say, up to 3 kilometers thick. It reaches 3,000 meters above sea level. The base is at sea level, or even below in some places. and it's only cold enough up there because of its own thickness. So basically it creates its own equilibrium.
Which is then different again to things like Arctic sea ice, which is stuff that
Yes.
sits in the water, which is will change year in, year out. So what we're saying is there's lots of different types of ice depending on where it's sat. Maybe it's sat on a continent, like in the Alps. Maybe it's sat on a pole, like Antarctica, or up in, which is on land. But then in the Arctic, it's in the sea. So there's lots of different types. I mean, the one thing that's definitely tying all these together at the moment is the threat of global warming and climate change. I mean, that's the thing that, I mean, ice needs to be cold
Exactly.
For it to survive. So what is the current state of, you're out in the Alps, you're an environmental engineer, you're studying out in Switzerland. Switzerland has, I think, more glaciers than any other country in the Alps. I think I'm right in saying.
I
that
think
true?
it does. It has like
I think so.
1,400 glaciers.
Oh my gosh. So what is the current state of the glaciers out there at the moment?
So, well, yeah, right now in Switzerland, all of the glaciers are receding and pretty quick, like only since the year 2010, I think they have been losing like 17% of their volume, which is enormous. I mean, just over 10 years. And yeah, the projections are also not very good. Of course, there's some that are bigger, like Aletsch Glacier, which is currently still about more than 20 kilometers long, and that can persist until the end of the century under, let's say, a relatively good climate scenario. But they're all retreating pretty quick. Mm-hmm.
And that goes across the entirety of the Alps. There's going to be, like, around the world, the way that the global warming's working, the way climate change is working, it doesn't necessarily mean that we're going to get less rainfall, less snowfall everywhere. It's going to be a little bit different here and there. And we'll get on to kind of worldwide view of those glaciers. But especially in the Alps, I'm seeing it when I'm out. I suppose all our viewers will be coming out to the Alps at some point for running or climbing or something. Anecdotally, I know that you study this kind of thing, but anecdotally, do you see it over time?
Oh yes,
just by looking?
Yeah, that's very important. Both as a runner and a mountaineer and as a glaciologist, because okay, we have been working for like 3 summers now on the same glacier, and its glacier tongue is reaching down to like 2,500 meters, and like you can visually see it receding. And actually what is impressive, we surveyed it with a ground penetrating radar. It's like a radar antenna where you can see through the ice to the bottom of the glacier. And like where we surveyed in 2017, now there's just rock, and a big channel collapsed. Like there was a big subglacial channel where the water flows under the ice, and it was melting out so quick from the inside. There was like a hollow that is like 5 meters high where the water was flowing. It all collapsed within 1 month. So yeah, you can see it, and also people who go frequently to the mountain, you can say that. You can tell that if you go on to, for example, the Haute Route in some summers, usually in the upper parts you always have snow on the glacier, and the crevices are well covered, so you can easily walk over them without major hazard. And now often they also bear ice, or the snow bridges are very small, so you can notice that very easily.
Wow. Yeah, I mean, I live in Wales, in the UK. We haven't had glaciers here for a long time. But I visit the Alps as frequently as I possibly can. But when I come back, kind of like annually, for example, I suppose it's like being with someone or knowing a friend, and they change over time. You don't necessarily notice because you're with them all the time. But when you see them once every kind of few years, you go, wow, that's a massive difference. So I definitely see it. But the one thing that I've been fascinated by for the past few years is the fact that, in the UK and especially in Wales, we don't see glaciers all the time. So we often see them on TV, on a documentary, but we perhaps don't go to them. So we might not think they do anything. But Exactly. I've been fascinated by the fact that so many people rely on them for water, electricity, agriculture, like all these things
Exactly.
matter, right? Especially in the Alps.
I mean, even us in the Alps, I think we're underestimating how many people are relying on it. I mean, we're just thinking about, oh, well, the people in the Alps, they rely on the glaciers, like for tourism, for water, and so on. But we don't realize, I mean, they feed the major rivers that flow into the European countries, right? They flow, I mean, the Rhine River, the Ahr flows into the Rhine. Then we have, the Inn that flows towards Austria. We have, all the major rivers, the Po in Italy, and so on. They are all fed from the Alps, and the same is true for other big mountain chains, right? The Himalayas, where starting from the Himalaya, there's these major rivers like Hindus and Ganges and the Yangtze and so on. They are all fed from the Himalayas, and they feed overall, well, we've talked about this before, like 1 billion people with water, and also hydropower, some of them. And the same is true for other parts of the world, like the Andes and so on. So yeah, I think many people in the Alps are not even aware of this. They just think, oh yeah, we have our hydropower and or maybe some agriculture and local drinking water from that, but they don't realize that it's all downstream as well. Yeah.
That downstream is the perfect term for it, because it's something in the region of 90% of lowland Europe gets their water in some kind of way through meltwater from the Alps. And like I say, the Andes will be there, the Himalaya. There's a bunch of different places that have these water towers that sit up high and are basically kind of storage facilities for, depending on how you want to use it, the water itself or the energy that you can get that's fed. You know, the water comes off, rolls downhill from gravity. You can use that in some way to drive a turbine and get hydroelectric power. I know Switzerland does that quite a lot. You guys get a lot of hydroelectric power, right?
Yeah, I mean, must say Switzerland has exploited, since we started like in the 50s, almost all of the hydropower potential that is possible to exploit, let's say technically, but also in terms of like respecting some minimum environmental standards. So 56% of our electricity is hydropower in Switzerland.
Wow, I didn't know that.
Yeah. So and what is crazy is like there's big dams, but also what people don't know, there's many water intakes that come from small valleys. So basically, there's maybe no dam in that valley, but they take the water from a small stream and they divert it to a big dam. So many small streams are also diverted to these big dams, and some galleries, they can be up to like 24 kilometers long, all through the mountains. It's insane. Like, and so, yeah, it's really, really fascinating. But also, I think nowadays, maybe, I'm not sure this would be built again, because you realize it's also a certain impact on ecology. But I think now we also have technologies to, for example, fish ladders and so on, to circumvent some ecological problems, to make fish pass, or, yeah. And then, yeah, as you mentioned, it's very important to mention, it's like storage power towers, like the glaciers. So maybe if there's no more glaciers, we would still have, I mean, we have a lot of precipitation in winter, then we have snow melt, and we have some rain in summer, but the seasonality strongly changes. And basically, what we don't have anymore is this huge storage of ice and basically then water that the glacier brings us. Yeah.
And I suppose it's important to say that, like, between the last ice age and now, we've already lost, like, what was last ice age coverage? About 32% of the land was under some sort of ice. And then now we're down to about 10%. So we've lost a lot. We weren't supposed to be losing I think the big thing is we were going to continue to lose it in some sort of way, but the pace at which now we're losing it has gone up massively. I think I saw a figure that was like 2/3 of, especially the Alps by the end of the century, of the glaciers in the Alps would disappear.
Exactly.
So, but it has practical ramifications, right? Like that's the thing I keep coming back to, is that agriculture is already kind of suffering in the high parts of the Alps.
Yeah, and also in the flatlands. I mean, we have had several summers since, for example, the summer of 2003. It's very famous for being very hot and dry, where we had big droughts for agriculture too. Then again, several summers like 2015 and also a bit in 18, where just, there was not enough water already. But what you, maybe it's important what you mentioned before about the ice age. It's important to mention, I mean, of course there was a natural cycle, and you have glaciers advancing, retreating and so on, but we're exiting the natural cycle basically by humans putting in way more CO2 into the atmosphere. Well, you've probably talked about that before, but like
we covered this,
like more than in the past 800,000 years, and so we're out of this cycle, and now we're entering kind of uncharted territory soon, I would say. And I mean, maybe you have seen this. There's nice papers about, for example, how the glaciers retreat up to the year 2100. Like that, for example, Aletsch Glacier. If we follow the RPC 8.5 scenario, it retreats like all the way. Like there's nothing left of any glacier in the Alps, to be honest. But then if we make a major efforts for climate protection and for reducing our emissions, we can save part of this glacier, at least a third of what's left.
Yeah, and I think that's important. I think that, you know, there are some positive outlooks on this kind of stuff, but also, like you say, the hydroelectric stations could stay there because of seasonal snow and rainfall. Yes. We might still get those. There's still going to be agriculture that can work in the lowlands because of that as well. It's not necessarily all doom and gloom. Yeah,
it's important to say that we can adapt to it, and we can. Yeah, of course it's hard because we have to adapt in a short time, and as what is also, there was a recent study by some Swiss researchers, is that if the glaciers retreat quick, we know that underneath the glaciers, from radar soundings, you know, there's some over-deepenings where the glacier like eroded the rock, and there's basically a potential lake underneath the glacier. When the glacier is gone, you could use some more surface for hydropower again. You could create smaller dams higher up. Of course, it requires a lot of effort and all. And of course, this would never replace the whole volume of storage that the glacier occupied. But you could use that. And of course, hydropower is not over, but then we have to use it in a different way, because as you mentioned, like, for example, for the month of August, the prediction is like by the end of the century, we would have 60% less water than we had like between the 80s and the year 2000. Yeah, for example.
Yeah. Well, I suppose at the moment with the glacier where it is, you take any glacier, that August might be the prime kind of like peak output because of the melt that's going on.
Yeah, peak is the key word. Like right now, we're actually already past peak water from most Swiss glaciers. So peak water is a term for when it's getting warm enough that glaciers melt extremely strongly. We measure that on our glacier. They melt up to like 10 centimeters a day in thickness of ice. And if there's still enough ice left and it's very hot, of course there's the most water flow coming from melt. We call this ablation as well. So from ice melt. And then, because the volume of the ice is reduced steadily, there's less and less water coming at some point, and the peak water is over. And we are already entering the phase where at some point less and less water is coming, because the melt is stronger and stronger, but there's not so much ice to melt left. So yeah, we are entering already the phase after peak water, yeah.
We started this before we started talking. I did say, well, let's try not to have it all kind of doom and gloom. It's difficult, isn't it, not to have that eco-anxiety and say, it is all going wrong.
Yeah, it's true. Yeah, I mean, you can also, that's why I try also to be optimist and say, okay, we can do something about slowing down climate change, and also to what's left. I mean, there will be warming anyway, even if we do big efforts. We can adapt, right? I mean,
and I think there'll be cooling in the future as well. Like, it's one thing, I really want to write a talk called "Why I Don't Care About Climate Change," and it's all kind of based on an astronomical projection of the the Earth, and it's like the Earth doesn't matter too much. I think we'll hit a point, as there has been in the past, where we get to maybe close to 0% ice on the Earth's surface, and then something will happen. We'll go back to a different cycle, and it'll start to come back. But it's the major impacts of all of this, including the glaciers, is how we deal with it, right? Like that's the big thing.
Yeah, I mean, the question is how can we live well still in this environment that's changing very quickly, and yeah, what we didn't talk about so far is, I mean, the natural hazards, right? Some may decrease, but many may increase because we have, as we saw, like on the south side of Mont Blanc, Courmayeur, there's a hanging glacier where they had to close part of the village down because it started sliding very quick. Like there's a lot of meltwater at the base of the glacier, and it lubricates the base and it makes it slide more quickly, and it could break off. So there's such hazards, but also glacial lake outburst floods. There was recently one, I think this spring was that in Himalayas in India, where there was a big, well, there was not a glacial lake outburst, but there was like more kind of permafrost related ice and rock avalanche that triggered then a big flood in a major river, and that killed many people. And such hazards, especially in the Himalayas, where there's less, I mean, it's so vast there, and there's less infrastructure, people are less protected against such dangers. There may be huge impacts. Also because it's bigger, right? The terrain is bigger, and there's still much more ice left, and will be also. So yeah, such hazards is one challenge, I think.
But like we keep saying with these kind of things, that I was just on a different call and saying the mitigation is the thing. Like we can't really change like projections for the like we're going to lose in the Alps maybe 2/3 of the glacier by 2100. However,
optimistic.
It's the mitigation part, right? Like let's try our best. It doesn't mean we shouldn't try better to reduce carbon emissions to make sure that the mitigation is like in terms of you mean like let's try our best not to lose too much. Yes. And even 2/3 is probably optimistic, but I mean, because the Alps, I mean, they are not that high, and there's not so many long glaciers left compared to the Himalayas or so. Yeah, and then there's but you're right, I think we should try our best, and because also to reduce the coast. I think what we saw also from the recent floods in Germany and so on, the coasts may be so high, like way higher than the measures we take against the warming. If we don't take them like fiercely enough and early enough. Yes. So what we're saying is there'll be less water, less electricity, less agriculture, more natural hazards, higher coastline. We've got our work cut out for us.
Yeah, now we didn't even talk much about sea level rise, but that's a huge thing too, right? I mean, that's more related especially to the ice sheets. Also the alpine glaciers contribute, but so that's
there's lots to take on board, Pascal, which means we'll definitely have you back for more conversations in the Arctic Climate Academy for sure. We got lots and lots to do, but for now, Pascal, thank you so much for joining us. I really appreciate it.
You're welcome. Thank you for the chat.
Thank you, man. It's really hard to. He put such a smile on. I can't help. I don't know what he's thinking.
Yeah, it was a good talk, but it resonates that we don't have much slag. Like we think like glaciers are something that is just static, and Pascal was talking about like the consequences of it, and it means that we don't have much slag. We probably need to do some things, and much of this warming it comes from the greenhouse gases. It comes from like the carbon dioxide that we put in the atmosphere, and they do all these effects that Pascal has been saying in the glaciers, and many other things that we hear everywhere. but actually, I just figured out like not long time ago what is the carbon cycle. That's something that we hear like carbon and carbon emissions and greenhouse gases all the time, but I don't think we really understand what's the carbon cycle, and it's also very important for life. Without carbon, we cannot live. So, what's the problem? And I think, yeah, I think you can illustrate us a bit more about what's carbon and what's the cycle of the carbon. That it needs to be in balance because we need it for being alive, but too much it can also, as we see, it can kill us in the long term.
Yeah, and chatting to people like Pascal, who is an athlete as well as a scientist, those key ideas, and you've set me up well for a little chat, a little lesson about carbon and the atmosphere. But yeah, Pascal really kind of epitomizes what the Athlete Climate Academy was for, which is like that balance between the two, right? That science and that athlete together. You outdoor, because athletes are primed, I think, and outdoors people in general are primed to kind of care about nature. And like you said earlier on, like Pascal said, like he sees it and you see it when you're out doing that. So yeah, the knowing the kind of basics is a good start. So thank you very much for that good setup, and a little lesson about carbon and the atmosphere. So let's crack on with Atmosphere 101. What do we need to know about the Earth's atmosphere and how it protects us and how it's changed? Well, the Earth developed an atmosphere a really long time ago, like really early on, about 4.6 billion years ago. And at the very start, it was hardly detectable. But as the Earth cooled down, an atmosphere started to form. And there was hydrogen, there's sulfides, methane, and about 200 times more carbon dioxide than there actually is today. It was hot, and we wouldn't want it to be around. But then it wasn't for another 500 million years that the Earth cooled down further and allowed water to form on its surface. So the Earth it's really quite unique as far as we know, in that it can hold water on its surface in large quantities because we're far enough away from the sun that water doesn't boil away as soon as it forms, and it's close enough to it that it doesn't just turn to ice straight away either. But it also exists as a gas in our atmosphere and as ice at the poles and in our mountains. So we really are unique that it exists in all three forms here on the surface. Like I'm pretty sure there's no other planet in the atmosphere, in the solar system or anywhere else that we know, where it does that, all three forms at exactly the same time. So there are other planets and moons in our solar system that have atmospheres. Venus is the most famous example, with a really hot, dense atmosphere that's made up mostly of carbon dioxide. It has a pressure of about 90 times that of Earth's, and it's 467 degrees Celsius on average. So not a place you want to go holidaying. But then there's also a moon, Titan, which orbits Saturn. It's actually my favorite moon. I'd encourage everyone to pick a favorite moon from the solar system. Like Europa's a good shout. Quite like Ganymede. Mimas is pretty good. Our moon is awesome, but Titan's my favorite. It has a thick atmosphere, a little bit like early Earth's, so it resembles an early Earth. But Mars and Pluto as well, they both have really thin atmospheres. So we're not unique in our atmosphere, just in the makeup of it and what it can hold. So our atmosphere developed in sync with life. So it was kind of made for us, and we were kind of made for it. So any changes to our atmosphere is going to impact the things that live here on Earth. And it's made up of around about 78% nitrogen, 21% oxygen, and about 0.9% argon and 0.1% other trace gases. So little bits of other things too, but oxygen and nitrogen being the biggest components. It's pretty useful, oxygen, to us, because it comes because we breathe it, obviously, and it comes as a byproduct of life here on Earth as well. And nitrogen is also pretty useful to life, and doesn't really react with anything else in the air or solar radiation, which is why there's just so much of it. Like I said, 78% of the atmosphere is nitrogen. And all the other gases will interact with the environment in a slightly different way and have different properties. But the big change over the past few hundred years has been the amount of carbon dioxide in the environment, and that has a few, let's say, predictable consequences. So carbon itself is a molecule, and it's absolutely essential to life. We are all carbon-based animals, us and all the animals around. So stored within us and all animals and plants on Earth is a lot of carbon. In fact, you guys are made up of around 20% carbon. Not necessarily in these places, like it's not just your legs that's 20% carbon, but then 10% hydrogen as well, 65% oxygen. You know, it's hydrogen and oxygen go together really, really well to form water. And then some other things as well. So that other stuff could be absolutely anything. But for me at the moment, 90 to 95% coffee in some shape or form. So when animals and plants then perish, the carbon and hydrogen can get stored with them underground or in the ground some way, sometimes at the bottom of the ocean as well. And it's a great way of locking up carbon so that it isn't in the atmosphere anymore. So the carbon dioxide in the atmosphere actually goes through a big carbon cycle. And that carbon cycle is something that we've studied a lot. Plants often kind of take in that carbon dioxide and use it for photosynthesis. Animals like us, we breathe it out as we respire. We take in that oxygen and we respire out carbon dioxide. Animals and plants, they naturally decay after they perish and they release it into the ground and the atmosphere. And sometimes in special circumstances, it can get locked in the ground and stored outside the natural carbon cycle. You'll see where I'm headed with this one. So crude oil and gas, crude oil, coal, gas, they're all fossil fuels. They were formed over millions of years, and from the remains of dead organisms. Coal was formed from dead trees and other plant materials, and crude oil was mostly formed, and the gas was mostly formed from dead marine organisms. The vast majority of coal that we find in the ground is from around about 300 million years ago. It was called the Carboniferous Period. And this is a time where plants and trees, they would grow to absolutely gigantic sizes, and insects were enormous as well because there was just so much oxygen in the atmosphere as well. So normally all this plant matter they would naturally decay over time, like it does now, because they'd be broken down by microbes and other creatures. But those microbes that would need to break them down back then, they just weren't around yet. So all the trees and the plants, they just started to fall on top of each other. And over time then, they would more and more would form, and they'd fall on top of each other, and under the weight, they'd form peat. And we still got peat bogs around the world today. But over more time, it would get crushed more and it would form coal. Oil is a little bit different. It's made of dead organisms like algae and zooplankton. And over the course of their short lives, they would take in energy from the sun. They'd store it as carbon molecules inside their body. And then when they died, they would sink to the bottom of the ocean, where those microorganisms, they just pile up over time as well. And over millions of years, that just built up more and more pressure, more and more heat. There's no oxygen down there for them to use, so they'd eventually form hydrocarbons. And in this case, they would form crude oil. If the temperature is a little bit higher, for example, they can actually form natural gas as well. So we know that different amounts of carbon was locked away underground. Fast forward a few million years, and a plucky bunch of humans realized that if you dig that up, the carbon bonds with that carbon bonds with oxygen, as does the hydrogen, and you can get heat. The byproduct of that burning process is what we know is carbon dioxide. And we've been able to extract heat from wood for a long time. But the thing is, you chop down a tree and burn it, and then you have to wait a long time for a new one to grow. So you can chop down a tree, you can burn it pretty quickly, but that new tree, to capture all that carbon in, is just going to take a long time. With coal especially, it's around 60 million years of wood and other plants all bunched up into a neat little coal seam that you can dig out the ground and then you can burn. And we don't really know who exactly were the first people to start burning coal. It was a very long time ago, but what we do know is that the Industrial Revolution in the late 1700s is with fossil fuel burning started to take off as a way to power machines, the ones needed for industry, and it became more abundant and cheaper to use than ever before. And people started switching from using it for locomotion, steam engines and things like that, to using it for electricity, a way of getting electricity. And the rise of carbon in the atmosphere then started to shoot up. This is a carbon dioxide molecule. It's got a carbon there. It's got two little oxygens with it too. And we measure it in parts per million. And pre-industrial times saw levels of around 280 parts per million. We're now on 413 parts per million at the time of this recording. Last time carbon levels in the atmosphere were this high was millions of years ago. And we know that carbon dioxide levels are increasing because of human activity. And we know that because, well, it's pretty obvious. We pump out around 43 billion tons of carbon dioxide per year. So it's kind of obvious that that's going to have something to do with it. But then also the specific type of carbon as well. We know that it's the type of carbon that comes from us burning stuff. So we used to live in a carbon cycle where the animals and the plants and volcanoes would work to produce carbon and then also capture it and lock it away again. But now that cycle's starting to get broken. The oceans can't absorb anymore. The plants and animals can't do it quite fast enough. And so all that carbon is just in our atmosphere. It's invisible, but slowly trapping heat and warming the planet. Carbon dioxide alongside methane and water vapor are all pretty good greenhouse gases, meaning that they're pretty bad, but they can absorb the heat that's let off by a warm Earth. So instead of all that heat just filtering off into space, or at least some of it, it hangs around in our atmosphere. And it's the molecular structure of carbon dioxide, and that lets it do this. And while methane and water vapor actually do it better, meaning that it's worse, carbon dioxide, there's just so much more of it. We're just pumping it out at such a high rate. And all this is to explain that how we got to where we are and how predictable it was to the people in the know. What's more unpredictable are the impacts that this will have on our planet and our populations and our biodiversity. And that's something that we're going to take a look at next.
That was great. I learned a lot on this talk, and as you mentioned, like it's all like falling together, but it needs to be in this balance. And you were mentioning at the end, like we put all the focus a lot on warming, on what's the effect of warming on. We mentioned like the floodings, the fires, the temperatures that they are raising, the glaciers. But you mentioned it in the end, like on biodiversity. Like biodiversity, it's something that it's there. We are part of it. Like we are one other animal. So I think sometimes we put too much the focus on the carbon emissions or on the climate. That it's very important, but we forget about biodiversity, and it's cool that now we have another athlete, actually, another super strong athlete that she knows a bunch of things about the biodiversity, because she's doing a great job about that in Chamonix.
Yeah, I was really excited. Like Hilary Girardi is, again, she's one of those people who is an athlete and a scientist together. I mean, you've known her a long time as an athlete, I'm sure, and she just goes out there and just smashes every race. But the science partner as well, she's working out in Chamonix, and she said if anyone's out there, you can stop by at 2 o'clock in the afternoon and she'll meet you for a drink. She said that. Not really. But yeah, your conversation with her was enlightening because, like you say, it is... We had to have a catch-all term for everything we do underneath Athlete Climate Academy, right? So we put climate, but it could have easily been the Athlete Biodiversity Academy, right? Like, we are all biodiverse, we are all bio things, we are all creatures. And you're right, we don't put enough emphasis on that, but I think we kind of felt that climate was a good catch-all for all of it. So I think more and more, if we can get more and more biodiversity, these things, the better, don't you think?
Yeah, exactly. I don't think we can get more biodiversity. We are like losing that like that game again. But at least I think we can preserve a big part of it. And I think Hillary have some very good and direct tips on how we can do as athletes when we are in the outdoors to not damage the biodiversity that is there, and also to try to preserve as much as possible for keeping this balance.
I'm super excited about this conversation to come because we are talking about climate a lot. We are talking about CO2, we are talking about the emissions, the footprint, but we often forget about biodiversity. And that's there. It's in our feet. It's just under our feet when we are running in the mountains, when we are cycling, when we are skiing, and it's a very important topic because without biodiversity, climate doesn't matter at the end. So I'm pleased to introduce to all of you Hilary Gerardi, that many of you might know as a badass athlete, but also she's also a good. She works for biodiversity. She works in the Crea Mont Blanc to study the ecosystems in the Alps. So hi Hilary, how are you doing?
I'm doing great. Thanks so much for having me on, Killian. I'm excited to talk about biodiversity and tell everybody about why it's the most important of all the subjects they're going to learn about in the Climate Academy.
Yeah, so let's go for it. Why biodiversity is the most important thing?
Well, so before I even go to like the why it's the most important thing, I want to make sure that everybody like has a pretty good idea of what we're talking about when we're talking about biodiversity, because a lot of times we think about it really just as visible things, but it's a really big subject, and it includes all the plants, bacteria, animals, us as well. Humans are part of the biodiversity of the planet, and so overall on Earth, we're talking about probably estimated around 8.7 million species that exist on Earth. And we've only at this point identified and really described about 1.2 million species. So there's still a lot to learn. It's a pretty huge subject. But in terms of why it's important, I think that for us as athletes, like you said, it's something that we come into contact with. It's also a lot about what we love about the places that we run, we bike, we ski. We can feel pretty directly connected to it. For example, like when you go out, like what do you love about being outdoors? Maybe it's like big forest canopies, maybe it's big green hillsides, maybe it's you really like seeing marmots or chamois when you're out in the mountains. Those are some reasons that it's important for us. But as you mentioned, I work for Crea Mont Blanc, which is the research center for alpine ecosystems here in Chamonix, and we try to study the impacts of climate change on biodiversity and then share that information and our methods with the public. And one of my jobs personally, because I do some fundraising, that's part of my work, is trying to convince people why it's important, why biodiversity and studying it is important. And I think that, usually part of that job is essentially relating it to humans and saying like, why is it important for humans? So like we can think about it in a lot of different ways, but I usually break it down to like economic reasons. That's one reason why it's important. Like they provide a lot of what we call ecosystem services. So fertile soils, pollution control, clean water, flood control, also things like fisheries, food, tourism, all that gives us money. So biodiversity can actually literally give us money. And then biodiversity has a lot of social benefits too. So the importance of biodiversity in different species, for example, for national or regional identity, you've got a lot of recreational value, like we said, for the sports that we do. We also place value in some different species. Or different landscapes because it's aesthetically appealing. And there's also things around health and well-being because a lot of, biodiversity, different species discovery helps us know how to better, do medicine better, for example. And then the last thing that I just wanted to point out was about cultural and spiritual benefits as well, because for a lot of communities, biodiversity, different plants and animals have a lot of importance in terms of, their customary uses, especially by Native and Indigenous communities. And there's a real spiritual benefit. So hopefully that's like a good resume sums up a bunch of different reasons why we should care about it, at least as why it's important for humans.
Yeah, it seems pretty important. It seems that it has a lot of angles to tackle, and it's important for, yeah, as you mentioned, like everything almost. And I believe that these connections that we are connected, we are not living in a world like we use resources for us as humans, but like we need all the other species on Earth to survive, and to just one single species alone probably could not survive on the planet. So we need to preserve. Probably we are bad on, like, we will lose some of this biodiversity. It's lost, but preserving a big part of it ensures our survival as a species too. So I believe that it's, as humans, if we are egoistic, if we want to survive, we need to think about biodiversity.
Yeah, absolutely. One of the things that I really like that you just said is the importance of the connections between different species. So like we as humans are really dependent on all of these other species that exist. We couldn't live without them, but there's also a lot of connections between them. And you're totally right. Like there's a huge threat to biodiversity. I think, some of the recent studies have said that like by 2100, we might lose 18% of the world's plant species, 22% of the world's animal species. Some sort of more pessimistic scientists or even say that maybe half of the species on Earth are going to be wiped out by the next century. But so basically, I mean, I think what's interesting is that there's so much left to know about it, and where everything is connected, and there are all of these interactions, and we don't know how all those interactions work. We as humans don't even realize that there are a bunch of species out there that we're probably dependent on, and we don't even know what they are. And so preserving them is really important to the extent that we can, because when you lose one species, even if you never knew it existed, you don't know what kind of like cascading impact that might have on the rest of the ecosystem.
Yeah, and when you're saying that, I imagine like the elephants or the pandas or the white snow leopards, that they are extincting, but it feels that somehow we know better the animals and the species that they are exotic than the species that they are close to home. Like I think if you talk with kids, like they will tell you like 10 animals, and they will tell you probably 10 animals that they are exotic, but not knowing what's the close biodiversity.
Lions,
and that's
tigers, bears.
Exactly. And then it's like, what's in your backyard? What's the biodiversity? What's the natural? What are the species living in your house? Like these small ants, or like spiders, or like the plants that they live. And we know less about that. And I think on education we need to learn more about like the species that they are surrounding us, because we need to preserve them too.
Absolutely. I mean, as I mentioned at the beginning, like, bacteria is also part of biodiversity, right? So like we know so little about a lot of these things. And so there is a need for a lot more scientific research. I think even around some of the bigger animals that you might be thinking of as well, we've realized through our work that like our knowledge, for example, of even alpine species in the Alps is pretty limited in terms of like in the Chamonix Valley where I live, what's the abundance, like how many, distribution, what kind of habitats they use, what are they dependent on? We don't actually know that much about it. So there's a lot of scientific research left to be done. And really important to, as you said, sort of recenter and be like, kind of in the same way that maybe a lot of us in the last year have stopped saying, I want to travel everywhere in the world. There's a lot to do right, in my own backyard. It's also, I can, stop learning about all of the animals all across the world. There's an awful lot I don't know, just literally in my house or just outside of my house.
Yeah, and you are working in Chamonix Valley, monitoring all these different species, and has it changed? Like, has it changed how the ecosystems are now compared to like 10 or 20 years ago?
Yeah, they definitely have. And so, I mean, the different things that impact biodiversity and impact sort of landscapes and things like that can both be directly because of climate change, and a lot of it has to do with land use as well. So like, you know, we see in a lot of Europe, for example, that there was clear cutting for agriculture. And so now we're seeing different kinds of forests coming back. But then we're also seeing things specifically in the mountains, you know, like the mountains are a pretty big biodiversity hotspots because you can get a lot of different habitats in a small amount of space. So like a mountain, you know, that goes all the way up like this, because the climatic conditions are so different, you can have all these stages with a lot of different conditions, and then different species that are adapted to those conditions. And with climate change in particular, what we see is that things are generally moving upslope in the same way that things are a lot of species are moving northward as well, or moving closer to the poles anyway, to try to find conditions that are similar. Studies basically show that for plants, they're moving upslope in a place like the Alps around 20 to 30 meters per decade. So every 10 years, you're seeing that going upslope. And then for animals, which can move a little bit faster than plants, as you can imagine, because they usually have legs or wings, they're moving more like around 30 meters on average. And what's interesting about that, well, there are a couple of things. One is that basically, right, if you have a plant species that interacts with its ecosystem and all the other species that live there, and one plant is moving 10 meters upslope, but the animal that usually is dependent on it has to move 30 meters upslope, you can see that there are like sort of these desynchronization and shifts. So we see changes in where they're located, but we haven't learned yet really what all the implications for that is, and exactly what that'll mean for the different species. The other thing that's interesting to think about is, right, because mountains are generally shaped like cones, there's less and less habitat as you move up the mountain. And so you can't, a species essentially as it moves upslope, can be losing in surface area. So the amount of habitat it has is definitely changing and generally getting smaller. In the short term, you probably talked quite a bit about glacial melt. In the short term, I guess we can say sort of it's good news for some plants and animals that there's some places there used to be glaciers, so they couldn't live before. And now that opens up a little bit of habitat that, for example, plants are colonizing when the glaciers melt, but it's not a great long-term solution for them.
Yeah, it seems that, seems pretty scary, actually, all you are saying. And you are saying that climate change is affecting this biodiversity, but I think that also it has a threat with over-frequentation of the mountains, over-frequentation of these natural sites, that they have a limited capacity of holding. Like it's not the same probably depending the species they are, depending the fragility of this species, how many humans can be in this area on a sustainable way. So I think we have a role to play on that, and as athletes that we are all the time training, going to outdoors to practice, we have a role on preserving these areas that we might love, but without knowing. I don't think it's nobody does because he wants to harm, but without knowing, we are harming them and helping this loss of biodiversity. So you're an athlete and you have all this knowledge. So what would you say? What should we do? What should I do when I go to run on a trail or to ski? To be a bit more friendly to the ecosystems.
Yeah, I think that's a really great question, and I think that we are seeing a lot more people practicing mountain sports, a lot more people seeing value in being in the mountains, and also as it gets hotter, right, lower down, people are seeking refuge in the mountains as well. So there are a lot more people, and you're totally right that we need to start being really deliberate when we think about, how are we interacting with these spaces. And I think there's a couple different ways. For me, I usually think about protection of biodiversity in terms of like passive and active. And like the passive is like, how can I do as little harm as possible? And active is like, I'm actively trying to do good. And I think a lot of the initiatives that the Killian Jornet Foundation is putting together are great things that will enact positive change worldwide. A lot of collective actions that will have sort of big, widespread impact. But in terms of like when we're out as an athlete, doing different things, I don't know, are you familiar with the Leave No Trace principles, which are pretty popular in the US? So that's something that I definitely think about, and some of those main principles can be applied generally anywhere, but they include, like stay on the trail, because, one of the biggest things around, loss of biodiversity is habitat loss. And if we are basically spreading out everywhere we go rather than kind of concentrating on a trail, then we're impacting that habitat on a larger scale. There is also, leave what you find. Kind of avoid picking, picking flowers, picking plants, taking things with you. You want to be disposing of waste properly. You want to be respecting the wildlife. And I think that's one of the big things, especially for people who aren't used to being out in an area where there is a lot of wildlife. It gets really exciting to like see it. Right? I want to get closer. I want to get a better picture of, that marmot or whatever it is. And the best is really not to be running after or approaching different animals. Definitely don't be feeding animals. I think that something else that we can do is that whether it's at home or when we're visiting a new area, is to learn as much as we can about how we can respect the wildlife where you are, because it's not the same everywhere you go. And so I think, sort of one example is if you're visiting a new place, or even if you live somewhere, is try to learn about what is going on locally, if there's habitat restoration, if there are wildlife reserves. Different places have seasonal restrictions as well about where you can go and what you can do. An example for skiing, I don't know if you've come across this, but some species really need calm places to like hibernate or to reproduce. And so sometimes if you're skiing, say there might be an area where you're not supposed to go because rock ptarmigan spend the winter there. And sometimes that kind of stinks because it's like nobody has skied there and there's fresh powder. But sometimes you have to kind of say, well, we think of this area as a playground, right? We oftentimes use this term. This is our playground. This is where we play. But we should be thinking about it also in terms of, this may be our playground, but in the end, we're visitors there. And the biodiversity that lives there, whether it's plants or animals, are really like the full-time and long-term residents of these places. And we're visiting their home, right? It's not my home. I'm visiting theirs.
That's a good point. Get informed, because as you mentioned, like it might be species that we don't know that they are living there, or it's their home and we are visitors. And I think that's a good resume on that. So it's a lot to do like on that. And as athletes, we have an important role on getting informed when we hit the trails or we go climbing or we go skiing. Sometimes it's not easy to get the information about that, but we spend a lot of time doing like a lot of research on like where to find like good snow or where to the weather forecast or gear wise. So we should spend a bit more time on finding about biodiversity. So thank you very much for that advice, Hillary. I think it will be very resourceful for everybody out there. And I think it's the job you're doing, both as an athlete, that you are amazing in all the races that you do, but especially connecting that to preserving the environment is just amazing. So thank you very much for being with us today.
Well, thank you so much for having me. And I think that, what I would love to say is that I think a lot like you, I see the mountains as a cool place, to perform, to push myself, to experience new things. But it's also a place that I like sort of, go to fulfill my needs, whether that's, or in terms of well-being. And a lot of that you can get a lot of that by sometimes slowing down as well, and really sort of seeing what you can observe and absorb when you're out in the mountains. And so keeping that in mind, and the fact that, we all have a role to play, and we all are legitimate in terms of who can talk about this and who can want to take action on this, I think is really important. And so I appreciate you having me on to talk about it. And I hope that it will inspire people to want to learn more and to get involved in their own local communities and however they can.
Thank you very much. Sure, it will.
Every single time I listen to Hilary, I learn something new. And I've listened to that before, and I've edited that, and I still learn more stuff. She's a wealth of knowledge.
Yeah, and I think what you say, that we always talk about our playground, like it's or as other people would say, it's our home. But we are visitors, and it's home for many species. And I think just understanding that deeply, it will help a lot to that, because like nobody wants someone like go to their house and start playing and breaking things. So we need to understand that we are not the only ones up there, and especially we are visitors, and we cannot be breaking the homes of these habitats. And I think that's something that I will try to do every time I go out, to just remember that I'm a visitor.
And I think that comes back to one of the reasons we wanted to start the Arctic Climate Academy, was to not only know, right, there's a sign that says I can't go onto that patch, but to know why I can't go onto that patch. So it informs our decision making and makes us better at choosing what we should and shouldn't do, if we know the reasons behind. There's something there that needs quiet because it's reproducing, or it's hibernating for the winter, right? Like knowing more helps us choose what we do.
Yeah, exactly. Like I got two little ladies, and of course, if they are sleeping, you don't want someone coming there screaming, "Yeah, super good powder there." You will be pretty mad at them. So I can rely that all these animals that they are like having babies, for example, you don't want to go there to scare them. And that's just not like that, but I think it's a good point to remember that it's remember that there are many out there, and that as an athletes we can do a good job. We can just understand, empathize, and also understand why. And you mentioned that's the most important. Why should we follow these rules that sometimes we cannot understand? And I didn't understand before, and I think over the time, like, you realize that it's not because they are taking away your freedom, but it's because you are trying to respect other species or other animals that they are as important as we are.
They are, and something that Hilary does really well is be a champion for all those different species, and that includes animals and the plants that are there as well, because as we know, those plants are having a hard time and the trees are having a hard time too. So in our next couple of sessions, we're going to be talking about trees, but I thought I'd show one of the videos that I made during lockdown. I mentioned that because I'm a little bit rounder in the face in the upcoming video than I am currently, or that I would like to be in the future. But it was for a wonderful organisation called Size of Wales, and who tried to plant as many trees as the size of Wales is. And we talk a lot about how we go to reforest things, how we rewild things. But I really wanted to give you a 101, because that's what I like to do on forests before we hear from Jim Mann.
When you think of a forest, you'll probably think of trees. And whilst trees are a very important part, forests are so much more. They have other plants and animals, fungi and lichens, and a wealth of microorganisms. So they really are huge ecosystems of living creatures. In effect, they're a vast expanse of land covered in trees. They're home to over 2/3 of the world's species and cover 1/3 of the land. They spread across the planet and are found on every continent except Antarctica. So let's take a look at a few types across the world. Boreal forests are generally subarctic and exist in places like Canada, America, China, and Russia. They exist where temperatures get really cold and are mostly coniferous. There are temperate forests found in America, Europe, Japan, and China, as well as South America, Australia, and New Zealand. Here the seasons are pretty similar and it rains year-round. Then there are tropical forests. These forests are some of the most biodiverse places on the planet, and what we think of when we think of a rainforest, found between the Tropic of Capricorn and the Tropic of Cancer. Each one of these has different amounts of biodiversity and looks slightly different too, but all forests have a pretty straightforward structure. There are 4 distinct layers. The forest floor only gets about 2% of sunlight. It's mostly decomposed in matter that dropped onto the forest floor. Then it's the understory. It gets up to 15% of the sunlight that falls onto the forest, so it's pretty well shaded. But you do get young trees and herbaceous plants living there. Then you have the canopy, home to 90% of the organisms found in the rainforest. They get a lot of light being so high above the ground. Other plants cover the branches and wrap around the trees. Only some push through to the emergent layer. The giant trees push through the canopy and into the sunlight. This sounds great, but there's less moisture there, the strongest winds, and the highest temperatures. Forests in general are very biodiverse, meaning that they have a lot of things that live in them. As an example, the Amazon rainforest, the largest forest on the planet, hosts 1 in 10 species. But 2 billion people worldwide depend on forests to survive. People live near them, people often live in them, and we use them for medicine and for materials. But so much of the Earth's flora and fauna, that's plants and animals, call it home. In fact, 80% of the world's land-living plant and animal species live in forests. So there's so much life in them, you'd expect them to have an impact on our planet, and they do. Forests do 3 things really well. They absorb sunlight, give out oxygen, and take in carbon dioxide. For that reason, the natural cycle of forests stabilize our planet. They give us oxygen to breathe. The Amazon alone provides up to 16% of all oxygen generated on land. Oxygen is built up in our atmosphere over billions of years, and our forests add to that. They also take in carbon dioxide from the atmosphere and lock it away. With climate change taking hold, that's something that we sorely need right now. The planet's warming more quickly than it should be. We're putting a lot of carbon dioxide into the atmosphere by burning fossil fuels. This traps heat in the atmosphere like a greenhouse, and part of the cycle to remove that carbon dioxide from the atmosphere are forests themselves. Luckily, they're taking some of the carbon dioxide out of the atmosphere, but it's not nearly enough. And these wonderful forests that are taking in that greenhouse gas are getting cut down too. We continue to lose forests at a rate of 1,500 football fields an hour. 17% of the Amazon has been cut down in the last 50 years. Forests are cut down for lumber, but mostly they're slashed and burned for agricultural purposes, mainly for cattle farming and soybeans that are used to feed that cattle. If we want to curb climate change, forests will play a pivotal role. Decreasing deforestation and increasing reforestation will go a long way to help slow the rise in global temperatures. So the Earth's forests are vast. They span the globe, are home to billions of living creatures, and help keep our climate in check. For more on biodiversity, climate change, and deforestation, check out our other videos. The next step for you is to try activity 1 below this video. Have fun.
That was good. That's forests are important, and as you mentioned, like it's forests everywhere. They are very different, but they have a similar role all over. And we were mentioning like deforestation. It's important problem that we are facing, especially in some of the latitudes. I believe in some of the other latitudes, it's forests that are also growing because the temperatures, because the temperatures are rising, and less agriculture. But many times when we talk about this natural or this reforestation in urban areas, not all the times is good. Many times, like it's done in a way that it's just like with a single species, and at the end of the day, like it don't helps on biodiversity or on carbon. So I think that's it's not as easy as like, okay, we are losing trees, we just put some more trees here. I think it's much more complicated than that.
For sure. And it's probably worth saying, obviously, underneath you, where I just said there isn't anything. So head to sizeofwales.org.uk they've got some great educational materials on there. But we put some on athleteclimateacademy.com as well for learning more about, well, all the things that we've been talking about, including biodiversity and glaciers and forests. But you had a wonderful conversation with our next guest, Jim Mann, about what they're doing to try and rewild, reforest, kind of bring back, but also link in the athlete community in that.
Yeah, exactly, Jim. I think he did a good job on like linking what athletes can do, what's the outdoor industry doing, with these consciences, with this reforestation in a good way, and linking with other processes that they can capture oxygen. So they can capture CO2, oxygen they need to put away. So yeah, listen to Jim, because he's a wise man on when it comes to forests.
So I'm super thrilled now to have Jim Mann here with me. He's a badass when it comes to what we can do for the preservation of the landscapes and also for climate. I think he find a very good way, very easy way for all of us to understand that some simple actions can make bigger changes. And first of all, let me introduce the man that is behind the trees notice that you probably has been seeing in some of the races when you are signing up. So, hi Jim, how are you doing?
Hi Killian, I'm good, thank you. Thank you for the very kind introduction.
No, it's a pleasure, and actually I want to go a bit back to your background. I know that you studied ecology in the university, and then you are also an athlete. Like you have been doing some big races and big roads. So what do you think is the connection between being an athlete and also like the passion for ecology?
So, well, I guess the ecology was always something that interested me. So studying ecology made sense. But I also, from quite a young age, was fell racing in the UK. So from a teenager, and when you're out in nature like that, I think you learn, and I'm sure you've got similar experiences. You learn to respect nature because things can change quickly in that environment. But you also learn to appreciate it and really like the environment that you spend time in. So little things really wind me up. Litter on the trails, for example. I'm one of these people who comes out with more than he brings home, more than he sort of takes out on the trail. I'll pick up litter as I'm going and things like that. But yeah, just that time in nature really makes you appreciate it, I think, as much as anything.
Yeah, and I believe that probably this connection between nature and fair running and the love of sport, it's what came on the building the trees notice. I don't know if all the folks here, you know what it is. It's an easy way, saying, okay, instead of having t-shirts given when you are entering a race or when you are finishing a race, to use that money to plant a tree. So instead of having a t-shirt, you are planting a tree. And I believe that that's a very cool thing, because it not only takes away the production of one t-shirt that we all know that will probably not be used for practicing, but it will be lost in some place in the house or in the car. And instead of you are planting a tree that will help to produce oxygen and to build an ecosystem. So how did it come, the idea of that?
Yeah, so I'd transitioned into trying to reforest the landscape. So looking at parts of the UK, we've got quite degraded landscapes, and I was trying to get trees planted. So I was already on that path, and at the same time trail running mountains, getting all these t-shirts. I've got a drawer full of t-shirts. I still have a drawer full of t-shirts, and I've sent boxes of them to rerun, because every race I was going to, I was getting given a t-shirt. Now, I'd actually stopped collecting those, so I was saying to race organisers, I don't want it anymore. But they're like, oh, we've already produced it for you. It's like, well, I'm still going to refuse it just to make the point that you should be giving us an option. But it took me a while to connect the two, and I think it was Dan Lawson at Rerun Clothing, that I'm a huge fan of, who are trying to sort of extend the life of running kit, who was always on about race t-shirts, and it just made me think if there was a way we could stop the race t-shirts before they're produced, and to use that to plant a tree to make people feel good, then and do something actually good as well, then that was a much better use of your whatever it is, £2.50, £3 that a race organizer is already committed your entry fee towards. You know, it's already in your entry fee. They're already spending that for you. So if we could divert that to something good and stop all these t-shirts which are heavily polluting, and we only see part of the pollution, part of that waste as it goes into landfill. At source, the rivers that are polluted through the dyeing process, the water that's consumed in making these t-shirts that we never wear, is absolutely shocking, and it's all exported beyond what we can see in most cases.
Yeah, that's a good point. Like to do like in a very simple action for the runner, that is just to click a button instead of in the registering process, to have two good actions, like removing like pollution, and at the same time like planting a tree. And I know that you have been we have been talking some other times about why it's important to the reforestation, and it has to be done on a certain way. It's not like just to plant trees, but it needs to be done with a sense, so it makes a bigger impact for not only for the capture of CO2 and the oxygen, but also for the ecosystems.
Yeah, and this is something that I think is all too often overlooked. We focus a lot on CO2 and not enough on biodiversity. And in actual fact, trees are one of the rare things that can actually tackle both. So we can put trees in the ground, and if we do it in the right way, we create habitat for wildlife. And when we think of wildlife, often we look at the large, fluffy, furry things that are cute to watch. But in actual fact, we need to come down that ecosystem and look at it from the ground up. So looking at the fungi, the bacteria, the insects, and creating habitat for those. So when we're planting trees, we've got foresters in the team who are experts on this. I've got an ecology background, but I'm not fully up to speed. I read lots of things, but I wouldn't claim to be a practicing ecologist by any stretch. But we take that advice on board, and we plant a mixed species and a diverse species, and we also plant to resist or to be resilient against climate change, because we're already looking at 1.25 degrees locked in. So that's where we currently sit today, and we need to plant trees that can survive at 2 degrees of change. And we're also planting in places where the trees will remain, where we've got very, very low risk of forest fire. You've been to Scotland, and I'm sure you're familiar with the amount of rain we get up on the west coast of Scotland. It's really not sort of tinder dry forest conditions even in the middle of summer. A drought is sort of a couple of days without rain up here. So we're pretty resistant to fire, but also the heat stress that trees can suffer means we're planting some species that would be north of their natural range, so that we know that forest is resilient into the long term.
Yeah, that's something. It made me think, like, it's many times when you want to do like a carbon compensation, like you look online and it's like hundreds of places where you can do compensations, and they are some that they are cheaper, some that they are more expensive, and probably the reasons are a bit there. Like when it comes to reforestation, probably it's not the same like to plant a mixed forest in a place where these trees will be treated and they will survive, than to make a plantation in some place that it will be desertic and monocultivation where they will probably disappear. So the effect can be strong at short term but not at long term. So should that be something that we look when we are looking for compensations, like carbon compensations? What's the source of this capture of CO2?
Definitely, and particularly with the two that concern me, particularly are soil carbon and tree carbon, because both of those are easy to reverse with management changes. So a chainsaw could reverse all of our carbon very, very quickly in our forests, but so could a natural disaster like a forest fire. There's one of the forest fires running through the Pacific Northwest at the moment is destroying actually as we speak, it's burning a carbon sink. There are 20% of a big carbon project is on fire currently. All that carbon will have been released, and that's not been planted in the wrong place. That's a pretty safe, would generally be viewed as a pretty safe place to plant. There are schemes that are in sub-Saharan Africa and they're planting non-native trees like eucalyptus, and there's a 1 in 30-year chance of that forest burning, and yet they're selling 100 years of carbon. I mean, that sort of stuff makes me really, really cross, because it's not a real offset. It's a scam basically, and the problem with that is it discredits everything that the genuine companies or people or individuals or charities are trying to do to tackle this problem, and it's going to keep happening. And so really that moves the onus onto us as individuals when we're choosing our offsets, to make sure we know where we're putting that offset when we're trying to do something good. Is it actually going to have a positive impact long term?
Yes, you mentioned like probably it's a market that is growing a lot. Climate, I would say it's more people that is aware. I think it's important. It's very cool that people is aware about what's the science behind climate change and biodiversity laws and all that. But we need to understand that with that it's also a market that is growing, and like every market, it's things that they are done better and things that they are done worse. So we need to do our research before, when we try to do compensations or when we try to invest on solutions that they are fighting on climate change. And I know that you are not only planting trees. You are not only planting trees. You try to go the full length on that. So can you tell us what are the other solutions that you are implementing in these landscapes that you are using?
Yeah, there's two other things that we're doing. So one is a product called Biochar, and this is taking forest waste. So when somebody clear fells an area of forest, and clear felling isn't necessarily the best practice, but timber is really important to us if we're going to decarbonise, because using timber in building materials displaces concrete, and concrete or can displace concrete, and concrete is far more carbon intensive than timber. So I'm not against timber harvesting and using timber for replacing other things, but none of our forests are cut. But what we do is go to forests that have been cut, and we take away what's left over, so the side branches that are left and the tops of the trees, and we process that into a charcoal type material. And the reason we do that is the wood that's left on the forest floor would rot down over the next 10, 15 years, releasing all the carbon dioxide and methane back into the atmosphere and creating more heat and more energy in our system, which is ultimately what climate change is doing. So we process that into biochar, which is a product that can then be spread on the ground and stores that carbon for 1,000 years. Basically, it's buying us time for decarbonising the rest of our activities. The other product that we use is a process called enhanced weathering, And actually, this is the one that I'm most excited about. And we're just starting to scale it up now. But we take a certain type of rock, and it's quite an abundant rock you can get all over the world, and we grind it up into a fine powder. And this is replacing a natural rock weathering cycle. So rock weathering removes depending on the estimate, between 10 and 500 million metric tons of CO2 from our atmosphere every year. And the process is that as water falls through the atmosphere, it absorbs CO2, forms a weak acid that reacts with the rock and chemically stores the CO2 as carbonates. That will store the CO2 for anywhere between 100,000 years at a minimum and 200 million years at the other extreme. So this is absolute permanent removal of CO2. And so we're now scaling this up. We're probably the leading company in the world to be making this happen. Working with the likes of Stripe, card processing company over in the US, who are helping to fund the research we're doing there, but also we're starting to now scale that up. And I think this has huge potential for removing CO2 cost effectively and relatively quickly.
Yeah, that's such a solution that we don't think often about. We think often about like how forests are like the lungs of the earth, but I was a long time ago, or like a few years ago, I read this study that big mountain ranges like Himalayas were like big lungs also for the planet, because exactly the rock cycle and how like rocks breaking can like capture CO2 and deposit for so much longer than than other solutions, and to take that and make it happening, not accelerating that, it's such a brilliant idea, and it's good that you are combining all the three different things to add. So it's not only I think that's the best, like to take all the knowledge that we have on how we can fight climate change and try to find the best places to do it, and that's a brilliant job that you are doing there. And to finish, I would like to ask you, like, you are an ecologist, you have this company, the Future Forest company, and the Trees No Teas, fighting for climate change and biodiversity. And you are an athlete too. So for me as an athlete, what are the best things I can do to fight climate change or to preserve the landscapes and the biodiversity?
So look at your carbon footprint. Understand your carbon footprint. Flying will be one of the worst things that we can do, and I know you've reduced your flying dramatically. So have I. And the other area, so transportation, your home heating, and diet. And when we talk about diet, it can be quite a polarizing topic. Eating local is largely the key. What can you source locally? What can you source seasonally? Heating your home, it really, that's quite a difficult one, because it's expensive to retrofit homes and to improve the way we heat homes, but things like heat pumps can make a massive difference. The coefficient of heating there can improve the efficiency of your heating threefold. And transport, we all know that flying less, using transport that's running anyway, so things like trains, great way to travel. Obviously pandemic makes that somewhat more difficult at the moment, and electrify everything, from your car to where we can put solar panels. We've got to stop burning that oil and gas and everything that is a natural carbon store. We've just got to stop putting that into the atmosphere. The quicker we can reduce those things, the better. So everybody can do that. Oh, and equipment. I should say equipment, shouldn't I? The shiny new stuff. Just because it's got a new colour on the shoes, don't buy them. If you've got tread left, wear it out.
Yeah, that's the best point. Like, use your gear. Like, it's not to be in a in the house. It's made to be used, and to be used for long until it's destroyed, and then you can repair it. So that's a good point. Yeah, so thank you very much, Jim. It's been a pleasure, and it's always so inspiring to see all the work you are doing, and for the folks, like, just check out the Future Forest company and learn about these amazing different ways to fight climate change and to fight like the biodiversity loss, and it's something that all of us can help.
Brilliant. Thanks, Killian. Thanks for having me on.
It's so good to have people like Jim doing work around, and also it's important to have like, it's very important to have like philanthropic options for fighting for climate change, for environment. It's very important to have like foundations like mine, or like your job that you are doing, like this show, like this Early Climate Academy, like we are doing, because for fun, and like because we think it's important and because we want to put it out. But it's like, it's just because we want to do it, and we don't want to make any profit out of it. But it's also very important that companies also work on that way. And I think that Jim is doing a very good job on like how to put companies profitable. So it's people working, it's people like getting a job on something that is important and is good. So I think other than everything he said, that I believe it's very, very important, and it's very good points that he made. It's also important to notice that we should work all together. Like I think like philanthropic options with businesses to accelerate and to make a real change.
Yeah, I mean, I was just so impressed with the breadth of stuff that they do. Like Trees Not Teas is one of the things that they do, that Jim does, and you know, the innovative science with the carbon capture through the grinding of, I think it's basalt, which I know that they do in Iceland, pumping that water back underground to capture that carbon. Just all these different ways. And one of the things that have come out time and time again during talking to the scientists and athletes about this is that there's no one way we're going to solve this, right? Like there's going to be little bits of everything. And Jim said this as well, like we need to do something here and do something there, and just, we can all have an impact, but we need to, I suppose, become informed through things like this on how we best go about having that impact.
Exactly. It's not one single solution. It's not like the solution, but it's small solutions or bigger solutions. But all together they can make an impact, and it's we need to open on that, not to try to find the solution, but to work on all those that they are around. And one of those is also like advocating and educating, maybe as we do. Like I think we can inspire people, we can connect people, and also I think the next guest, he's doing a very good job on that, on connecting also athletes and young athletes with scientists. So yeah, can you introduce him?
Yeah, he might be watching right now. Who knows? His trail running camp, his footprints is running right now this week. So he might be running. He might be watching this with all his team. Dakota Jones was wonderful, and I kind of just gave him the helm really, and said, talk to us. Tell us what we can do in the mountains to help us become better advocates and protect our mountains better.
Hello, everybody. My name is Dakota Jones. I'm an American trail runner. I grew up in Colorado, which is just incredibly lucky. I grew up in a place really close to where they hold the Hard Rock 100. So I've been running in basically the coolest mountains in Colorado since I was a kid. And that was my introduction to trail running and to outdoor sports in general. And ever since I was a kid, I've wanted to climb mountains, and I wanted to ski, and especially when I first volunteered at the Hard Rock 100 when I was 17, I found like, this is what I want to do. I love these mountains. I love this sport. I want the adventure. I love the community most of all. It was just this perfect combination of all my favorite things in life. And that's why I've built my life around trail running. And what's so special about trail running in particular, like I think more so than road running, is that we have this connection to the landscape we run through, which is quite unique for running, I think. It's a shared experience with a lot of mountain sports, but I kind of feel like, I mean, road running, track and field, is so interesting, so much to do there, but what's special about trail running is like every course is different, every mountain range is different, so everywhere you go is unique, and over a matter of hell, 15 years now, I've been learning how important that landscape is to the sports that we partake in. And that gives the value to what we're doing. And ever since I was, in my early 20s, I've wanted to protect the places that we play because, as we all know, there are a host of environmental issues that are damaging the landscapes that we love most every day. And the biggest one, the most encompassing problem, is climate change. And as we've all seen, there's a million examples, but climate change is already affecting our cities, our coastlines, and our mountains worse than ever. And so what I wanted to do, starting probably 5 or 6 years ago, I was like, how can I use what I love most to protect what I love most? I think it's really easy to take this attitude that by humans are doing things that are damaging the environment, so what we need to do is just stop everything. And that's true to a certain extent, but it's also not possible to a certain extent. People live their lives, and living our lives requires using resources. And that's okay as long as we're very conscientious about how we do it and why we do it, and we take care of these resources so that they are sustainable. And mountain sports might seem like a luxury. In fact, it is. We have the luxury to go out into the mountains for hours, days at a time and challenge ourselves, sometimes extremely hard. And that's a luxury. It's not luxurious necessarily, but we have the time and the money and the, food or whatever to do these things. And so what's best about these sports is that we have the community. The reason you're watching this right now is because we are part of the same outdoor community. Whether you're a trail runner or just interested in trail running or outdoors in general, this is something that we all share. We're part of this world, and we have similar values, we have similar goals. We love working hard in beautiful places. And so what we need to do is just use this community to protect these beautiful places. And that's the big problem, is like we haven't come together as a group as well as we need to. And so when I look at how I can protect the places that I play, the reasons I'm doing this is so that I can continue to appreciate this, and so that I can pass on these beautiful places and experiences to future generations. And I think that we can't do that by just not going to wild places. Because really what's happening is, the problems are not necessarily coming, not always from the mountains. It's usually like industrial activities far from the mountains that are affecting the mountains. However, that's not always true, and we do need to lessen our impact. And that really gets onto this, I guess, duality. That's a big word. Dichotomy, that's an even bigger word. How about let's just say there's two sides to this issue that I think about. There's like personal actions. What can an individual do? And then what can we do like as a society? And what I try to do in my work now is I want to bridge that gap. What can the individual do to support the larger issue? And I started working on this, I think 3 years ago was my first really big effort. I rode my bike. I did a bike tour from my house in southwestern Colorado up to Colorado Springs, and then I ran the Pikes Peak Marathon, and then I rode back. And the reason I did that was because I was like, driving up there, it's going to use gas. I don't want to contribute to climate change. And what I was doing was I was trying to set this example. I was like, for me, what's most important is protecting wild places, even if that means sacrificing my experience. Even if what's most important for me is protecting wild places, even if that means sacrificing my ability to race. However, I was like, ideally, I could do both, right? I thought maybe if I could prove that you can ride your bike to a race, live in a sustainable manner, and then do well, and then come back, like that's a great example that I can set. And it worked out perfectly. You won't believe how perfect. I couldn't believe it. I won the race. I biked over there, biked back. We raised over $11,000 for Protect Our Winters. Because people were following along. It was a good story, and I loved it. It's one of the things I've done that I'm most proud of. But it's also made me think about a lot of things. I rode a bike made out of steel, which required coal to manufacture. I wore clothes that were probably made in Taiwan. I ate food that had been trucked hundreds or thousands of miles. That doesn't make me a bad person. I was doing the best that I could. But I also have to acknowledge that if I'm trying to save the world, my bike tour isn't going to do that. Even if I bike tour everywhere for the rest of my life, that's not enough. However, if we all start taking these actions, that might be enough. Either way, it changes our relationship with the landscape, and it changes our outlook. If not just for me, but for everybody, if protecting the places we race is more important than racing, then we're going to have a stronger culture, I think, because we have a shared interest in protecting a place that we all acknowledge is fragile and can change at any moment if we don't protect it. So this has led me onto this camp that I'm doing, which I'm wearing the shirt in my shameless advertising, totally okay with that. It's called Footprints Running. And my thought there was that I'm going to bring out a bunch of mountain athletes to Colorado, and we're going to help them take the actions that they're most capable of. Because there's also, with my bike tour, you have to acknowledge that I had the ability to take 2 weeks off of my life. I didn't have, if you have a job or kids or honestly like a whole host of other normal parts of your life, if you have these things, you can't just like disappear for 2 weeks or a month or whatever to go ride your bike to this place, run a race and come back. And so it's almost like I had this incredible luxury that most people don't have. And it's unfair for me to ask you to take the same action. However, there are actions that you can take which are unique to you and your circumstances, your knowledge, your means, anything. You are all more capable than you believe. And I want to help empower you to do that. And so I started this camp with that idea. How can I help people be the best that they can be within their own means? And then I had to realize that, like, okay, I'm just a mountain runner. I'm not actually an expert. Like, what business do I have teaching these things? And so what we did is we hired people who do have business teaching that. And we have experts in environmental sciences and in public policy who are teaching our campers, each of whom has a project. And the campers learn from the experts and then apply those lessons to the projects. And the idea is they go home after the camp and put those projects into action. And so as we work through this camp, our goal is to bridge that gap between individual action and large-scale action. And that really gets down, I think, if you maybe are familiar with Protect Our Winters, it's largest in the United States, it's expanding, but it's this organization that is using the outdoor industry to mobilize people to take action on climate. And specifically, they work in the political sphere, encouraging people to vote and to call their representatives and to get involved in the legislation that will make the changes. Because what's really going to stop climate change is when we have government mandates that require renewable energy, electronic vehicles, and all these large-scale actions that an individual can't affect, but the government can. However, on the individual level, if you're just trying to communicate with the President of the United States all the time, you don't feel like you're making much of a difference. It does, but it's really hard to see that change. And so what we're trying to do is we're empowering people to take their individual actions and see that success. And if you go down to your grocery store and you're like, we're not doing plastic bags anymore, this is how we're going to do it, it's going to be better. You create a whole program and you succeed just in one spot, that's incredibly empowering. You see how much you can do and how capable you are. And then you might try it again somewhere else. And then you expand up and up and up and you become a leader. You become a mentor. People follow you and want to learn from you. And then they go on and do their own projects. And that's how we're going to scale up the climate movement. That's how we're going to scale up climate action. We're going to show people that they're capable of individual actions that mean something. And then we're going to empower them to make those actions larger and give the tools to more and more people. And so it's a big honor for me to be able to work with the Kilian Jornet Foundation because he is doing this, the foundation and Kilian are doing this work better than anybody that I know. They're bringing people together, scientists, athletes, brands, events from all over the world to become this united whole that is moving forward to show people that from every level, whether it's what shoes you choose to buy or what, gigantic renewable energy projects your government's going to support. Whatever that is, anywhere along that spectrum, these actions matter and you're capable of it, and you just have to find where you're at along that spectrum and then take that action. I think of it sometimes in terms of debt consolidation, which is a weird kind of random analogy, but I think it's true. People sometimes have a lot of debt, and there's like debt for this credit card and debt for this house and all this thing, and you can consolidate it, and they're like, you should put it all together into one giant debt and then pay that down. But it's not a good way to do that, because then you have this enormous amount of debt. It's really the same amount, but it's gigantic. Whereas if you line all your debts up from small to large and pay off the smallest one, that's a victory. And then you pay off the next smallest one. That's an even bigger victory. What we're trying to do is we're trying to make the entire world run on renewable energy using carbon-free technology. That's a gigantic goal. But if we just go down to the grocery store and get them to stop using plastic bags, if you encourage your neighbors to invest in a group of solar, in a solar rooftop project, anything like that, these are small actions that mean something, and you're capable of it. And so I hope that you'll follow along with both the Kilian Jornet Foundation and my Camp Footprints, because we're creating tools for you to take action at your own scale, by your own means, all over the world. So, thanks.
So thanks.
I'm so proud of Dakota. He's an excellent runner, and he's a great advocate about climate change, about environment, and he's taking his adventures, his races, from, as he mentioned, from the individual actions to the bigger commitments, and I think he made a good summary on how we can act on an individual level and also on a more global level, and I think he really nailed it on that.
Yeah, and there's always like great partners. Like we chat about, there's so many people now doing similar things, and we're all pushing in the same direction. You mentioned Protect Our Winters, which does wonderful work all around the world. That his Footprints running camp, that follow Footprints running on Instagram, they are doing stuff right now, which is pretty crazy. Trees Not Teas and just everyone else. Like, we've been so fortunate. This last 2 hours is just the tip of the iceberg, but we've been so fortunate to come across so many wonderful people doing such awesome work.
Yeah, I think the end is to connect people with different knowledge, that together we can have ideas, just to get to know more, and I think it's these connections will make the difference, because many times it's not because we don't want to do better, it's just because we don't know how, or we don't know where to start. And I think it's listening to people like Pascal, Hillary, Jim, Dakota, or many others that we can know more, and we can start to find our path to do better for our future, for the future of the planet too.
And we wanted to make sure that this was at least a little bit kind of like back and forth and a conversation. And I think we've talked we talk enough over the last kind of 9 months, but we reached out this morning to a few of the followers of, I think, Climate Academy and yourself, and I weirdly got less questions back than you did. I'm not overly sure why that could be, but that is no idea. But that it's important, right, to have for it to be a conversation and not just kind of speaking at people. Did any of them jump out at you as important questions to think about?
Yeah, actually, it was a bunch of people that was asking things, and actually it was many people interested on what to do to reduce our impact when it comes to gear, when it comes to the industry, what the industry is doing, how our gear and how we can like buy better to have a less impact. And that's pretty good, because we will not answer the question right now, because tomorrow I think on Thursday we have someone that will do that better, no?
Yeah, and I've got a whole lesson lined up for you, Kilian, all about the gear that we use, what it's made from, specifically looking at like textiles and that kind of stuff. It's a tricky situation, because manufacturer obviously produces things and impacts the environment. However, there's ways and means that we can think about it better. That's a great question, which we will tackle Thursday.
Yeah, and don't forget to go to the website, to the adultclimateacademy.com, and you can find some sessions with experts, and you can watch them as a YouTube video or in the podcast. So it's actually one also about industry, so you can go there and have a look on that. And then it was also many other questions about the environmental policy. What we can do as individuals, and how we can push the governments. And I think on that Dakota did a great summary on how we can do it, and we need to understand that our actions as individuals, it might not make a big effect, but it influences the people that is close to us. But also, it's things that we often don't look at, like where we invest our money, like what's the bank where we have our money, what are they doing with that, or the insurances, or I think the financial world has a lot to do, and also that when we vote in the elections, but we are also voting with our wallet all the times that we are going to shop. So I think that's we can make policy to change. We can change policies on talking like with our voice, with our channels, but also like when we go to elections, to voting, but also when we are going to shop or using our money.
Yeah, and I know that we talk about like what does the Athlete Climate Academy do, and I think as a way of educating, I think we do that really well. But if you're going to say what does Protect Our Winters do, that kind of movement, and I know that later on in the year they're going to have a big push around that kind of activism and where do we put our money. So definitely check out Protect Our Winters for more on like the activism policy side of it, because they do it so well.
Yeah, exactly. And like as you mentioned, like Protect Our Winters, they are doing a great job, and go there, like get to know what they are doing. Also, like Dakota in the footprints, they are actually running or like having some lesson right now. So go to check what's going on there. And on that, like we are also like I got some questions about like the events and like the tourism in the mountains, like how we can be because I read like a study like a few months ago about the impact, the carbon footprint of different sports, and even if other people they have the higher like knowledge about like the climate change, we are the ones that we have the higher emissions of carbon. So how can we change as a as a as an industry, not only on the fabrics, but also like on events, on like tourism to practice all that. So that's a big topic, and I think we also have soon like some of the episodes for you on that.
Yeah, and it feels like you're kind of setting these up for me to hit. But on Thursday, we've got two wonderful young athletes who are talking about, their choices going forward and what they are willing to give up for, what they're trying to reduce. Is the events that they're not going to go to because they're just too far away, the carbon emissions are going to be too much, or there's plastic pollution, or all these other things. And then a wonderful team at Kendall Mountain Festival talking to them about they've actually co-funded a PhD researcher to look at what are the impacts of outdoor events and festivals, but also I know you guys at the Kid and Shawnee Foundation have done some wonderful work in this. What is the impact of like a big trail running event, for example? And one of the things that I think we think about a lot, and it's something we definitely want to push with Athlete Climate Academy, is this as a science advocate, we don't think about answers before we think about the problems, and we have to identify the problems first. And it's something that we're trying to do time and time again. In trail running events, it seems that it's kind of obvious that there will be a problem, but do we know what that is? Like, let's find out what it is first before we go try and tackle it.
That's the way to do it. Identify the problem and then find the best solutions. And yeah, we will continue doing that on the program, on the live streamings, and also in the website where you can find all these different videos and all these different materials. So I encourage everybody to go to visit the website and to find these all these materials that you can use for learning yourself, but also to share with your friends if you are working in schools, or if you are doing a presentation on a race, on an event, anywhere like this material is there for you to use to spread the word, and we are counting on all of you to share all this information. We hope that it has been helping, and I has been learning a lot today, actually, just listening to all these guys. And I hope that I'm sure that I will learn a lot more on Thursday, where when we will have the second session. So when are we doing that?
So that's going to be, it's always difficult with time zones, but 5 p.m. Universal Coordinated Time, which is UTC, which is the scientific standard for time. It's going to be 6 p.m. British Standard Time, which is British Summer Time, which is me at the moment. 7 p.m. Central European Time, which is your time. Yes, for sure. So that's going to be the same again. We got some wonderful, same kind of format. We got some wonderful people lined up to talk about. And if there's any questions in the meantime, get them into myself or Killian, and we'll do our best to answer them in Thursday's session too.
That sounds perfect. So thank you, everybody, to be watching this, and we meet you in a couple of days.
We certainly will. Diolch yn fawr iawn. Have a very nice rest of your day, Killian. We'll see you all soon.
See you.
Bye for now.